of advent of code in F-star. F-star is a general-purpose functional programming language with dependent types. So you can write proofs about your program's correctness and express properties about your types that the compiler verifies. I'm using F-star. You can't run programs directly in F-star, but you can extract programs to OCaml, and that's how I've been solving the advent of code problems this year. So we've got about 5 minutes left. You can see I'm 1 star short. I have not managed to go back and solve the second part of day 8. I think I need to build up some libraries for working with finite sets. Advent of Code is sponsored by Akita Software, among many others, this year. Check out our jobs page. We're hiring engineers for our startup working on API observability. And it's a great team. I'm very happy to be back working at a small startup again. Although congratulations are due to all my ex-coworkers at HashiCorp, who had their first day as a public company today. They did their IPO, and it's a big milestone for them. So, checking out the leaderboard. Yep. I did pretty good yesterday. Had my second best, I guess, part 1 score, even though it took me a half hour, and improved that a little bit for part 2. This was a fairly long time to write a DFS, and I've thought a little bit more about how could we go back and actually prove to F-star that the DFS actually terminates, so it could become a total function rather than a function with the ML effect. And I didn't come up with any great ideas. It should be the case that we can show that we only visit a particular square at most 4 times. And so we could keep a list of all the squares we've visited and say this will never get larger than so and so. But I'm not really sure how to prove any of those to F-star. So for resources on F-star, you should check out fstarlang.org. There's a tutorial there that is very helpful. There's a new tutorial being written that is somewhat less helpful because it's less complete, but this is actually how I got started, and it's got a interactive F-star environment built into it. There's a wiki on the F-star GitHub page. Refer to that, although it's kind of hard to find stuff, and a lot of it is inside baseball. It's what are the plans for the language, how is it implemented, things like that. So I saw that Eric just announced some new Advent of Code T-shirts. I am sad to say I don't have an Advent of Code T-shirt. I'm actually wearing a roguelike celebration T-shirt today, but it's cold here, so I'm bundled up. So the company I founded back in 2008 had its IPO in gosh, it must have been 2017. It's sort of like a big wedding. You go, you take a bunch of photos, you clap a lot, you mingle, you take more photos. I hope it was not too cold outside while taking photos out in Times Square next to the NASDAQ Event Center. They list HashiCorp listed on Nasdaq. You don't get to ring the bell when you list on Nasdaq. You just go to the event center and press a button. But it counts. All right. Any predictions for what today's puzzle is going to be? We haven't had a virtual machine or assembly code problem yet. We might be due for one. One year I tried solving in a language I wrote, and I couldn't get a multiplier to work. And so that hurt a lot on the assembly language programs. Okay. Navigation system is made up of several lines containing chunks. Okay. Interesting. Okay, so it's a parsing problem. Okay. All right, so we need to find the first illegal character and score it. So it's only the first illegal character. Okay, so I wrote a very janky recursive descent parser for f star, but I think that would be the wrong approach here because it would be difficult to return in that framework to return what we were expecting but didn't find. But I think recursive descent is still a good bet. So one of the tricky thing I discovered while working on that is again the termination condition, proving to f star that we successfully all right, let me grab the example and save that, and the puzzle input and save that. Successfully proving to f star that the recursive descent parser terminates was tricky because we had to prove that it got a lower string each time, and that made it very hard to write parser combinators. Okay, and our input is gigantic. Okay. Okay, so we've got square brackets, curly brackets, angle brackets, and parentheses, right? Yes, parentheses. All right, so let's try to write I'm going to write out the types first. So let's have a let's have a parse result, and that will either be okay or an error, and what character we were expecting. So in fact, why don't we use lists instead of strings? Okay, but if it's okay, this isn't the right syntax. I'm messing it up already. I'm blanking. When did I last use this syntax? There it is. All right. So if it's okay, we want to return the rest of the string. And so that we can continue parsing it. And we want to say that that is shorter than the original string, which is how I got in trouble with my recursive descent parser before. Is it going to be better to do a stack-based parser, maybe? Yeah, let's do a stack. Okay, so one way we can do it is we can take in we can give this type an argument that what was the input and guarantee that if we give an okay, then we return the unparsed portion that is smaller than what came in. I think so. That can be made to work, but it's sort of hairy. And I actually had to invent a whole bunch of lemmas about string suffixes to make it work, because I actually guaranteed a stronger condition was that the return value was a subset of the input. Let's build a stack instead. So parse stack is either empty or it's got an open square bracket or it's got but for all these we want to take what was the previous stack. So that we can pop back to it. Okay. I think that should be good. All right. So we're not going to have separate functions for parsing each of those then. We're just going to have one function that does stack-based parsing. Okay. I still think we need a result. We could get that. We can just return the parse stack, right? So if it's empty, then we successfully parse the line. If it's something else, then we know what we were expecting and didn't find. Okay. Great. And so we can give it empty to start and give it the input. All right. So let us match what's on top of the stack. So if it's empty, then we can take anything. Okay. First, we need to check if the input is empty. Okay. Match the input with, if it's empty, we just return whatever's in the stack. If we've got a current character and the rest, then let's look. So there are two ways we can use these types. We can match on a parse stack and pattern match what's in there, or they get constructors. So I'm wondering, is it better to match the stack or to match the character and just check what's on the stack? I think the okay. All right. So let's just put all our characters here. Dang it. Okay, square brackets, curly braces, angle brackets, curly. All right. And anything else is an error. We'll just return the stack. It'd be nice to signal an error. Maybe we could add error on if we need as another type on the stack if we really needed it. Okay. So we can always open a new curly brace. That's fine. So the opening braces are always allowed, and that means we just push something onto the stack. So go on and parse, and that is square and the old stack. Wow. Is that it? That seems pretty easy. And notice the termination's taken care of us because it already knows rest is shorter than the input. So, angle curly. All right. Let's see if that type checks or if we've made a equals. All right. I evidently yes. Okay. It's colon first. This syntax gives me a lot of trouble. Because it's sort of like the match, but not quite. Needs to be a let. Okay. Needs to be a let rec, in fact. Have to say whether, okay. If we need to define more than one mutually recursive function, we could do it all in one big let rec clause. I haven't had to do that for advent of code yet. Okay, so for a close bracket, we need the top of the stack to be exactly the matching character. So if it's empty, oh no, if so that checks if it's a square. If it is, then parse the rest of the line with the previous stack and the rest of the input. All right, it's unhappy about something, but I don't know what. Oh, I actually need to call the function. Okay, there we go. Hey, all right. So let's just tighten that up a little bit so it's easier to copy it. Oops. Although I am an Emacs user, I'm not actually a very good one. I don't know most of the key bindings. All right. So this has to be print. We could define a function that actually did all this and just took the constructor, I think. But I'm not sure. I'm not sure constructors have a type. I would imagine they do. I've never tried that. All right. Oops. All right. So let's see. We need to score a line. So we do that by parsing it. Parse line list of string s. Convert the string to a list of characters. And then if we so if it's empty, it scores 0. Let me pull that up. If it's a square bracket, square, and we don't care what the rest is, it's a curly, that is 197. If it's an angle bracket, wow, why are angle brackets so valuable? It's a parenthesis, 3. Oh, we need to give it the empty stack to start with. All right. Let us copy our code from yesterday to do I/O. And let's see. So going to return an int. I'm going to turn on. All right, I'm just going to make this int, even though these are all natural numbers. So I'm going to read the line. We reach end of file that's 0. So we take the score of the line plus the rest of the input. I feel like we ought to maybe print out where we failed, but let's give this a try. We didn't import sprintf, which is called confusingly just called it's the module's printf. All right, let's see what happens. Okay, our score is not correct. All right, let us change. Let's split this up. So score of and we will return a parse stack. Okay. Good, yeah. All right, so we're gonna should we just make something to print out the whole stack? Maybe not. We might have to do that if I can't figure out where the bug is, or I guess the easy thing is just check that all those are correct. Yeah. 357. Okay. And then we want to return. Oh. Too many arguments. Oh, I didn't use printf. All right. I really should just write a helper function that does both. All right. So parse and print. Oops. Okay. Let go. All right. So now we're reading, printing out each line, and let's just do example. I thought so. Yeah, we're reporting every line as if there's a parsing error. So we're okay. I'm looking up what we were expecting, and what we're supposed to return is the first illegal character. Okay. All right. So let's score the. All right. So we gotta fix a bunch of stuff up. We still may have other problems because okay. This is tricky. Since some of the lines aren't corrupted, just incomplete. So if we reach the end, that's fine. What we're looking for is the first illegal character. So character. Okay. Square. So that's going to be a closing character. Okay. Now, all right. So So we want to return a char. We'll use space for no error. Oh, let's do it right. Returns the first character. Okay. So if we reach the end, it's a none. Otherwise, we just need to return what character it was. Oop, all right, that type checks. Okay. If it's some other character, we shouldn't get that, but we need to assign a type to it. Say that the function does something, or else put in here that the only characters it can return are on a particular list, and then we have to go up a level and do that here too. So maybe we'll do that if we solve it. Okay, so okay, so that actually stays the same, I guess. Yep. All right. All right, that looks better. Yep. So let's try it on the whole file. I bet in part 2 we're going to be asked to do something different with these incomplete ones. I hope our stack is well suited to whatever it is. All right, that's part 1. Yeah, so we're just going to repair them by popping characters off our stack. Thank you. All right, so we're going to autocomplete. All right, let's just copy part 1 to part 2. Rename that. Okay, so every completion character is, for each character, multiply the total score by 5 and an increase by the point value. Okay, so for the last one, start with 0, so we do that in order. Okay. And we have to take the stupid median again. All right. Well, we can resurrect our median finding code. Okay. So let's have this return, go back to returning the parse stack. Oh no, so now we need an error. So I'm gonna add an error type. Okay, so if we get empty, we return the stack. In all the mismatches, we return error. All right. So to score, let's see, it says we discard, not score. I think I saw that here. Yes, discard, that was the first line. Discard the corrupted lines. Okay. Parse stack. I'm going to do the previous score. All right, so if we reach the end, it's just whatever we previously scored. If it's okay. Previous, okay, it's going to be previous times 5 plus 1. Oh, I need to do a recursive call, and this is matching the wrong thing. So it's completely wrong. All right. I don't know if we can say that there's a parse stack that doesn't have an error in it. That error type's a little weird. what we'd have to do is say that the previous was never in error. Sure, let's do that. Not why doesn't it like my negation? Oh, it's mad about my incomplete function here. Okay. I guess this is not gonna work. Feels like it ought to, but it looks like the tests are not defined until like all the helpers are not defined until the end. Okay, so we could do oops. All right. This may be a bad idea. I'm looking at parameterizing the type. So then we could say previous has to be a parse stack that isn't an error, and it returns one that isn't an error. But then I don't think we could do this as a return type. I think we'd have to do like a dependent pair or something to say what type of parse stack it is. So I'm gonna is there another option I'm not thinking of? So I'd really like to filter out the errors and then know that I've done so, but I mean the other option is we could, instead of having the error type, just use an option like we did before. But I'm gonna live with this, I guess. All right. Okay. So paren is score. All right. So parenthesis has a previous. So score the previous. Oh no, I'm using previous two here. Score the previous stack with I'm having to use multiply here rather than star because star is by default re reserved for creating pair types. There is a module I can import that defines it, but I've just gotten into the habit of not using that. All right, so paren square square is 2 points. Curly is 3 points. And angle is 4 points. And this function needs to be recursive. Okay, so each thing we add on the end, we're going to start at 0, multiply the previous one by 5, add our score, pop the stack, and go on to the next one. All right. Okay. So we're going to return a list of integers. So we parse our line if it's an error, then just go on to the next line. Else we're gonna add the score of S onto the rest of the input. We need to do okay, I keep forgetting to do that. Score S starting at 0. All right, if we're going to clean this up, we'd make those auxiliary functions, and so we would not have to pass the 0 values in. All right, so let's find our median code. That was day 7. Oh, and this is when where we needed to write our own lemma. The lemma we needed is that sorting preserves the length. So let's open. yeah, there are a couple lemmas in the F-star standard library about the correctness of sorting, but neither of them, as far as I can tell, is sufficient to tell F-star that the length is the same. So, um, in order to make this call to index, it needs to know that middle is less than the length, and so that's why we have this lemma to tell it that that is in fact the case. All right. Okay, so parse input gives us back our list, and we just want the median of S. I think we have to prove that that's non-empty. Yes. All right. So if S 0 all right, let's try that out. Well, that's not so good. Okay. If we reach the top of the stack, then we want to return the value we've. All right, let's write a type that catches that. All right, so the naive one is say this returns a score that is greater is greater than or equal to prev. Now that'll fail on the error case, which we said returns 0. So if we yeah. So this this would be more compelling. Huh. So why doesn't that hold? Okay, we need to know. We need to make these natural numbers because otherwise it could get smaller. There we go. So I'm bothered that we have the error state in here. I'd love to refactor to get rid of that somehow, but I went through that and I didn't find a good solution. But if we had written the type there, then that would have caught our error. All right. 288957 looks good. All right, we got both parts, and just under an hour. Yeah, scored pretty well tonight. Yeah. So let's think what we can do about this parse stack problem. I guess the simplest thing is not signal errors on the stack. So go back to an option type. If we run out, and then, we do a sum stack, and all these errors become none. And we can get rid of that weirdo case, and we can say if what is the way to get that out? I guess the easiest way is just match it. There is a function in option library. No, that's just the Boolean check. All right, let's just match it. I guess we confused it. There we go. You can see OCaml complains about all sorts of warnings in the generated code. It often does that on matches. All right, I'm happier with that. I don't know what else we could prove here. Let's. We could write a unit test by asserting that this worked, but I think we're done for the day. Yeah, I feel pretty good about that. We certainly missed the opportunity here to catch our problem by not writing a more specific use case the first time. And one thing we could do is futz about with saying, well, the chars, we could define a type that's something like legal character equals a character where C equals, all the legal options, and then parse line would know that those were the only possibilities. But it seems kind of silly to have our parser do that, because one of the things a parser would be checking in real life is, but what if the input doesn't fit that? Okay. Well, happy Advent. I will post this to GitHub shortly after writing up some notes on the solution. Thank you. And we'll see you tomorrow, hopefully. Good night.